Hi and welcome. I hope everyone is okay. Now, in this lesson, we will pass the new chapter, chapter 4. Our chapter name is Continuous Random Variables. Okay, now we can start. Why do we study continuous random variables? This is the most commonly encountered continuous random variable since many natural occurring phenomena such as length of index finger or time of natural sleep or the speed of car passing a particle point on a road consist of continuous data that can be described using a normal distribution. Introduction to continuous random variables. In a survey, data were collected on the time each of the 425 patients waited to see a doctor or nurse. 257 patients waited up to 30 minutes. 132 patients waited for the 20 minutes to 60 minutes, and 36 patients waited for 60 minutes to 120 minutes. This continuous data described in 3 class intervals can be represented in a histogram as shown in the following diagram, which plots the waiting time in minutes in 3 class intervals. Please notice that this histogram graph, our histogram graph related to patients, and we have 425 patients, but in 425 patients 257 patients waited up to 30 minutes, and then 132 patients waited for 30 minutes, between 30 minutes and 60 minutes, and we have 36 patients waited for 60 minutes to 120 minutes or 2 hours. So in this histogram related to frequency density, please remember that from the statistic 1 we used to frequency density. Frequency density means frequency over width. Frequency density equals to frequency over width. So this means for the first class 257 over width. Our width is 30 minus 0, so it means 30, and approximately like that 8 points, etc. And the second one, frequency density, is 132 over 60 minus 30. It means 132 over 30, and approximately that, as you look at the as you see the graph, 4 points, etc. And the last class for frequency density is 36 over width, 120 minus 60, so 36 over 60, it means 0.6 as you see in this diagram related to frequency density. But if we use to more smaller glass intervals, for example, instead of instead of between 0 and 30, uh, 0 and 5, between 5 and 10, between 10 5 20, between 20 and 30, etc. Our diagram becomes like this. So if we go on, our intervals makes more small. For example, like this, between 0 and 5, between 5 and 10, between 10 and 15, like this, our graph like this. If you notice that our graph becomes this curve. For example, for the first graph, our curve is like this, and for the second graph, our intervals are more small than before intervals. So our curve is like becomes like this. But if we make our intervals very more small, for example, we have more column, so our curve becomes like this. Our curve, as you see the very approximately normal curve, we can see that the shape of the histogram begins to approximate a curve. If we use the probabilities of waiting times to calculate relative frequency density, then the graph will have the same shape, and the vertical axis scale is probability density as shown in the following diagram. In this diagram, related to probability density, but the before diagram related to frequency density. If you notice that both diagram, if you notice that these both diagram, they are very similarly. So the second diagram related to probability density. Please notice that the first diagram related to probability density, the second diagram related to frequency density. So both diagrams are very similarly. Please remember that from statistics 1 lesson course, we could find probability density is frequency density over total frequency, or the sum of the frequency. For example, for the first column, our frequency density is we can find for the table. For example, we have 14 patients. Our width is 5, so frequency density is frequency over width. Our width is 5 minus 0, so it becomes 2.8, and this point is 2.8. If we want to find the probability density, we should make this process. Probability density is frequency density over over the sum of the frequency or total frequency. As you remember, we have 455 patients. 455 patients. So the total frequency is 425. So 25. So the probability density is 2.8 over 425. So if we calculate this process, 2.8 over 425 becomes 0.006. So 0.006, 0.006 is this point is like this, 0.006. So if we want to, for example, I want to look at the table. For example, this column, for example, this, if we want to find frequency density, I used to this formula. So frequency density for the fourth column is frequency over width, our column width. So 20 minus 15. So 51 over 5. It means 10.2. So 10.2 frequency density between 15 and 20. 15 and 20 like this. 15 and 20, this column. 15 and 20 is this column. So this point is 10.2. 10.2. So if we want to find the probability density, I should make this process. Probability density is frequency density. Frequency density, it's also 10.2 over the total of frequency. So we have, as you remember, we have 425 patients, and then 10.2 over 425 patients, our probability is 0.024. 0.024 like these, for example, this situation, and 15 and 20 area is D. This probability density to 0.024 our probability density. If you think in reverse it, if you find the column area, for example, for the first column, you can find frequency. This column is rectangle, so this distance is 5, and this distance is 2.8. If you find the this area, 5 multiply 2.8, so it becomes 14. 14 gives you frequency. 14 gives you frequency. If you look at the table for the first column, your frequency is 14. For example, if you think in the reverse, for reverse it. For example, for the this column, this distance is 5 and this distance is 10.2. So this area is 5 multiply 10.2. You can find 51. So area gives you frequency. This area gives you frequency. For example, if you look at this table at interval 15 and 20, you can see your frequency is 51 patients.